Single variable data. 5-number summaries. A data set may have lots of pieces of data. We have looked at measures of central tendency and dispersion which aim to reduce large data sets to a small number of statistics that give us a picture of the data set. The 5-number summary is a way of doing this, which makes use of the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. These 5 pieces of information can be represented pictorially on a diagram called a box plot. Consider the data set listed here. From this data set we can identify the median, the lower quartile, and the upper quartile. If you can't remember how to do these, refer to earlier lessons. So we have a minimum of 9, a lower quartile of 10, a median of 12.5 because it's halfway between 12 and 13, an upper quartile of 14, and a maximum of 18. And we can represent that on a box plot. So what I'm going to do is first of all indicate the values: minimum, the lower quartile, the median, the upper quartile, and the maximum. We then form a box around the quartiles like so, and we have stalks at either end. Box plots are useful. If you think about the box going from the lower quartile to the upper quartile, the length of the box is the interquartile range. If 18 is the maximum and 9 the minimum, the overall length of the diagram is the range. We can often spot features of a data set such as symmetry or skewness using a box plot. Now consider the following data set. It's actually the same data set, but I've replaced the maximum value with 25. The minimum is 9, lower quartile 10, median 12.5, upper quartile is 14, and the maximum is 25. We know from previous work how to calculate outliers. We do lower bound is equal to the lower quartile take away 1.5 times the interquartile range. Here, that's going to be 10 take away 1.5 times 14 take away 10, which is 4. For the upper bound, we do upper quartile, add 1.5 times the interquartile range, and in this case, substituting our values in, that's going to be 20. There are no pieces of data below 4, but the 25 is an outlier. We can show this on a box plot. So what we do is very similar to what we did before, but we don't indicate the 25 because that's an outlier. The next piece of data is 16. That's not an outlier, so we indicate that as the maximum. And we then draw the box plot in the same way as before. We then indicate the outlier like so.